The way you touch, the way you generate the data, right? I mean, it depends which interface, it is coming from machine, it is coming from human. The format of the data will be decided by that, by the source system, right? And I'm saying system, but it can be object. Human is an object. If I'm speaking, the voice is being recorded, it may be a voice data. And when you think about an application generating the data, it may generate a very structured data set that you create table, student info, and then you put a lot of columns, right? So that's a structured data. Think about social media. You are writing, all the time WhatsApp. You do a lot of things on WhatsApp today, right? I'm sure everybody is using WhatsApp. Think about the kind of data that it generates, right? So anything that we are doing, there is a touch point. That touch point generates the data. Every touch point generates the data. It could be that could be captured from the sensors. That could be captured from the very real interfaces. Anyhow, the question is, why I'm capturing those data? Because I think there is a value inside that data. Let's put it in that way. I may suspect there is a value inside that data. That's fine. There's a value inside the data, but before somebody can process that data, it has to be well architected so that I can socialize that architecture before even he makes a use of it. Correct? I mean, take a very classical example. If I ask for a needle, right? You go back to your home, and if your sister asks for a needle, where is the needle? You know where exactly I need to look for it, even if you don't know the needle, where it is, right? You know where there is a room and there is an almirah, you can go and pick that particular needle. Why? Because in your house, in your room, there is a layout, there is a structure which defines what all things should go where. And that depends how faster can you retrieve it. And here we are talking about a huge house of data, where I'm going to make a huge house of data wherein I will store all the data one after another. And if I not organize that data really well, then how can you expect your retrieval time will be so less? No. I mean, you have to learn how to organize this data into such a format which is really usable. And if I make that super easy, it's super easy to get access on that particular data, extract the information which is hidden inside that. It's a puzzle, right? You are trying to find the analytics which is hidden inside the data. So let's try to make that puzzle really easy, and this is where I always say data architecture helps you. One of the principles in data modeling and data architecture that we always follow, it's a dream for the industry, by the way. Guys, you can stop me if you have a question, otherwise I'll keep on speaking. So, there is a we all know what a design pattern is. There is something called design pattern, right? Guidelines and principles and a lot of other things. One of the principles that data modelers always use, design for unknown. Design for unknown meaning is, we all agree that there are multiple variety of the data. It could be voice, it could be paper, it could be video, it could be something else. And really, knowledge is hidden inside this everything. But now you think about you are following a principle, design for unknown. Where is that common model? Which is that common data structure which will help you to store all this data onto one particular into a canonical structure, which will make your data analyst or data scientist really easy. They can understand and they can churn that data. Making things generic is one of the best practice. We always think, can we make it generic? Can we make it generic? Go from generic to specialized, don't go other way. That's fine. Data architects takes that particular pain. And since one of the use cases that we are trying to solve here is the analytics. Analytical model, if you talk about, we started with dimension modeling, okay? So we collected, in the previous example, we started collecting data from all our transactional systems, right? And we dumped into one particular database. And that time we were thinking the same thing was the question I was asking, right? What is that generic data model? What is that generic data structure that can solve everybody's problem? And why everybody's problem? Every analyst's problem? Because of very simple. Because of you are collecting multiple sources of data, and if you For 400 tables each system, 400 multiplied by 6 system, let's say 2400 tables. Right? 2400 tables, are you going to analyze? Are you going to make a join? Your database gives error of out of memory error or whatever exceptions that you get, even in joining 4 tables and processing 5 TB of data. And here we are talking about petabytes. So, lot of these problems can be solved by having a very good generic data architecture. Lot of these problems. One of the endeavor that we took to come up with dimension modeling. One of the try, wherein we keep all the dimensions in surrounding and we keep the real fact table which contains the measures and the numerical information into one central table. Why we did that? Because, and why we published this particular model? Do you think it is different than an ER model? I mean, from create table statement syntax perspective, absolutely no difference. You don't create a different syntax, you don't write a different syntax to create a dimension model. It's the same syntax. Conceptually it is different. Why we published and socialized this particular model? Because we wanted to introduce a very common data model to all of the data consumers who all are trying to do the analytics, who all are trying to consume the data and extract the information. If this is the common language, if this is the common data structure, so what is the data structure? If dimension modeling was the common data structure, then I don't need to teach you. You already know this is a dimension table, what it should contain. What all I need to tell you is, this is the dimension, this is the fact. Now go ahead and do whatever job that you want to do. Right? And you are intelligent enough because I know that dimension model is the model to process that particular data. Very good. It worked really well, dimension model. But think about collecting data from multiple sources. Now, you are collecting your product table from 6 different sources. And trust me, I was working for a very huge retailer, US retailer, and that time so different teams were presenting the same thing, how much sales have we done for stores. And trust me, store is the same, right? I mean, it had more than 4,000 stores. And every other numbers were different. All were from same store and the sales. You know the reason? And probably you can tell me the reason why. Because of that same sales data is being stored into Teradata, same sales data is being stored into Netija, same sales data is being stored into Greenplum or somewhere. The moment when you take that particular data, you are touching that data, you are giving a different shape of that particular data, and when you churn that particular information, it gives a different number. Because of you apply some filter, because of you miss some data, because of the timing when it arrives that particular data and all those things, right? So data architecture perspective, when you think, I'm also keeping my eye on the timing. But my meaning to tell you is, data architecture has turned out differently in Hadoop area. Doesn't matter which model you bring the data into. I have seen people taking data from data warehouses, bringing to Hadoop, and at some point in time, they are having a roadmap to switch it. Switch it meaning is give data, supply the data back to data warehouse. We can talk about those all architectures. But here, what models really work best is go for a very flat and very simple data model, which may be much more denormalized. Okay, so in dimension model, if you think about, it's mostly in the third normal dimension format, right? Wherein you have a foreign key relationship and foreign key child relationship with your fact table and dimension table. The disadvantage of that guy, if you have 1,000 number of reports, if every time you are making your product join with your fact, so 1,000 number of reports multiplied by number of requests. Right? So 1,000 number of tables multiplied by 400 number of users multiplied by 10 times being accessed. See how many times you are doing the same compute again and again, joining these two product and sales order time. Sales order, right? So it's a duplication of compute. You are wasting the CPU cycle. You are wasting the entire computation. Why can't you do that once beforehand and then you store it into very simple denormalized type of data structure? Expose that data structure to everybody. And for exposing, I told you one design pattern I told for data modeling called design for unknown. But when it comes down to exposing that particular data that you have stored onto your platform, there's another design pattern that I always suggest to, and it is again a dream. We have been trying our best to get there. Can we expose data as API? Okay, can we expose data as API? Don't try to write another API layer, and I'm not talking about technology, I'm talking about conceptual, right? Can we, so in other words, the same statement can be restated as, can we expose such a generic data model, generic data structure, which can answer you most of the questions? And as if, in a very easy way, meaning is you should not be bothered to process the data again. You are calling as if you are calling an API, give certain inputs, it will tell you the output. Are you always bothered about what is happening inside? Can we make our data models like that? I do have 400 of data analysts in my organization. Can I make sure that I create such a data model which answers all of the questions? And how easy can we make this? The degree of ease, it all depends on how complicated your data model is. Try to stay away with normalized model because it increases the level of computations. Do it once and try to flatten those all structure, keep it into a denormalized format so that everybody can take advantage of it. But if you do that, I'll talk about the security which is at the end. Because a lot of data computation and a lot of things will be joined, and then how will you manage the security? Let's talk about this guide. This is a very important thing, metadata management. How many of you know what metadata is? Alright, so I'm sure if I ask this question, everybody will tell data about data, right? But have you ever thought about the logic which is hidden behind this statement, data about data? Answer is yes, you might have thought, I'm sure. But I'll tell you my version of it. The way I take this statement, data about data, let's do a little bit of change. Information, every information about the data, which talks about data, like size, who accesses it, what kind of data it is, it belongs to who is the owner, anything that talks about that particular thing, those all I'll qualify as metadata, but not the actual data which is being stored, right? The actual data is still data. But anything that talks about that can be qualified as data. The question is, so far in this subject we were talking about how to organize the data. Now we are talking about how to organize the information which talks about that data. Right? So that the data model that you created, how to keep that. Well, we have heard about a lot of tools like Erwin, data modeling, enterprise architect, DB developer, a lot of tools available in the market which helps you to develop the model, and it also collects the metadata out of it. Good. We don't have only structured data, we do have unstructured data as well, right? We do have movies, we do have video clips. I'm sure he is recording this particular session and it will go somewhere inside one of the data platforms which will be stored. And somebody will do some analytics, how long, how short, what was the effectiveness and all those. So, the question here is that the attribute of data, it all depends on the perspective of the users. Okay? And if you try to classify the audience of your enterprise in a very generic way, one user that you can say they are the business type users. Another hand, you do have technical users. And in between, there are few people who are hanging in between called BA, analyst. Right? I use the wrong term, but the one who understands technology well, understands data really well, can bridge the gap between the business and technology team. Think about giving a framework for those three guys to locate where the data is. I was talking about data is the only IP. And if this is the only IP, and the size of that data is in petabyte, the number of objects are not countable, huge in the number. obviously I need to have some index wherein I can go and search for that particular data. And I can do my searching job better if I get a better index. Index not for Oracle, index not for Teradata, index for the data that I have stored onto big data ecosystem. I'm not talking about that index that you create index table, right? I'm talking about such a place which can really redirect to the physical location where that actually data exists. And it's pretty simple. If you came here from all the way from, making the entry and all those things, I'm sure you might have a very guided way, okay, go here, turn here, left, right, and then go up to the 10th floor. When you started from your home, you might not know where I have to go, on which floor or maybe, right? But you came here, it was so easy to reach here, at least from after entering inside the building. Why? Because the information which talks, the information which is really your end goal, make it available and easy. Whatever the facts was needed, it is available to you in a very organized way. There was a direction, right, written. So, maintain your managed data. It is super important. Otherwise, you will not be able to locate the data where it is. And I'll tell you 5 categories in which you should actually you can classify your metadata. Remember these 5 categories because this is very important from metadata standpoint. Business metadata, technical metadata, security metadata, governance metadata, and operational metadata. Right? Operational metadata meaning is if you have brought all those data onto your big data ecosystem, how frequently that is being updated. Right? Is my data set is updated? What's the retention rate of it? Okay? How frequently this data is being purged? Who all are accessing this particular data? So all sort of this information. Data quality, I'm not going to speak much, but you can classify the rules and you can really profile your data, how healthy my data is. Why it is needed? Why it is needed? Data quality is needed, why? Don't you think that the information that I collected, I have to rely on that particular information, this is the right information that I collected. Why to do this quality check? Any guess? Don't you think this is a waste thing? Do you agree this is a waste or this is a useful thing? Useful thing? Tell me one reason why it is useful. Anyone?
Different data, when you capture data, is different in different systems. They may not reconcile to each other. So you have to have data quality so that this is the reconciliation of what you have stored versus what you intend to store. And that's where the data quality is.
Perfect. So, okay. Alright. So data quality is very important wherein you may have to have a business rules and their executors, implementations, how healthy my data is. Because if your data will be healthy, your analytics will be healthier, right? And then visualizations, you all know visualizations. Data security is something that has been targeted as one of the topic. Maybe it's next topic will be data security, I'm not sure. But yes, there you can see the data security. But one thing you be aware from the governance standpoint, that if there is access, you need to audit that access. How frequently is being accessed? One of the typical example, if you are having a mobile number, email number, or email ID or whatever it is, you should actually try to see, the degree of audit that I'm talking about, how frequently people are trying to access and how many number of audits how many number of failure attempts were there. So like on an average, your credit card number was being accessed 200 times, but one day, all of a sudden it was 4,000 times. I'm sure there was something wrong on that particular day. Somebody was trying to access. But the question is that you should try to answer here. Are you tracking these many number of, these sort of KPI? What's my on an average access rate, success access rate? And if someday it is greater than that, then there is a threshold, then you should actually say, okay, there is some problem. So that degree of security audit that you should do. Alright, hope you, this session was informative. I didn't get time to ask. Oh, we do have question answer time or no? Oh, we have 10 minutes, okay. So maybe we'll go for Q&A. Yes, please.
My name is Anand. So the question is about talked about the governance and multiple layers inside it, right? So do you see any opportunity for a master data management here?
Yes. So opportunity for master data management is there, and it's very important and paramount important, I would say, to manage your metadata, master data management, right? So master data management, when I say it's a very vague term, very high level term, but when you break it down, data harmonization, data synchronization, syndications, right? So syndicate your data, harmonize your data in a way that same catalog is being accessed towards everybody. It's very important, and you can really do it well in Hadoop. Yes.
Hi, my name is Amit. So, in governance, would you also consider backup and restore policies for your big data?
In governance, I would say anything that touches the data governance is around it. There has to be governance. Like how frequently do you take backup? The backup has to be the policies has to be set up for the retention period, for the refresh frequency, how frequently that backup can be, whether it should be real time, and who all can access, and where that DR cluster has to be. Is it going to be to the same location, same geography, or it has to be a different country? And so every country has their own rules, right? Because your data center is outside. So yes, it is a governance topic because there are a lot of attributes that goes towards the governance. Any other question?
Hi, everyone. So this is Samir. So as per whatever we discussed earlier, so if our data is in a Hadoop system, in which the data is placed everywhere in the different location, what are the tools and how do you maintain that people have access to this data and how can you ensure that right people have access to right data?
It's a very good question which will be answered as part of this guide in this session. But it also depends on the distribution. Keep it short. It also depends on the distribution because software comes along with that. So if you are on Cloudera, you may use Sentry. If you have Hortonworks, you may use Ranger. But the important thing is you need to set up authentication and authorizations layer. Authorizations layer and authentication layer, in terms it looks very easy. But before even you go ahead and implement that particular tool, you should have the policies in place. So governance gives you that particular policies. How many profiles do you need? And each profile will map to which role, and those roles will be which all privileges. If you have this particular template, then let it be Ranger, let it be Knox, let it be Corpus, let it be any software. It's just one implementation. You can do that. And in this particular topic, when there will be session, you will get more detail.
And just to extend that reply, we have the same section focusing on security, authorization, address, data encryption, what have you said, like cross, all those things will be covered after the break. After the stage, there will be another session, but after that, there will be like from 1 o'clock.
Thanks.
So, stand by.
Yes.
What are the top few things that you look for data quality from governance?
From governance perspective, the top 5 things that I would say is there's a guideline from governance. They say check for the correctness, completeness, accuracy, and integrity. So these are the 4 things. The 5 things, it all depends on how you manage the rules. But for me, if you look at my experience, I have spent more than 10, 11 years into this industry, especially playing with the data. If you don't have really a very good rule engine which supplies the quality rules, this is very hard to manage, regardless which tool you use. And it has to be scalable. So the smartness is there how to manage those rules and qualify the rules.
Yes, yeah. Please pass it.
Hi, this is Bala, and first of all, it was a nice presentation here. So in your statements, you have explained about a single data structure or a table, I can say. Each requirement will be fulfilled, right? So on that, I have a doubt. So if my requirement is very simple, let's say, how many transactions have been cancelled on a daily basis, and that would be a different, that may be a small table where only transaction details would be there. But if I put this table with all the other details like viewed, browsing details, everything, product information, store information, everything. So is there any chance that a small query will take a lot of time when it is trying to scan all the data? Even though if I use the indexing partition, it may try to fetch a huge amount of data, right? So is there any chance that it will take more time when I keep it in a separate table?
To answer your question in a very short way, yes, there is a chance of performance degradation because of you have to scan the overload. But it's not the challenge in big data ecosystem because you do have technology to help you to decrease the narrower size of the data based on your request. And if you are not happy with that, go for key value type of pair, wherein your data structure you can make it so that it will be very narrow. Even if you go for the denormalized kind of format, you can select such a file format, maybe ORC, maybe Parquet, or maybe some sort of format, wherein it will minimize the page scan size. Because the page scan size in early days were 8 KB. Here it's MB, right? So still you can play around with the file formats.
Sure.
Yeah.
And encryption and decryption also comes into security layer, or?
Encryption, decryption come into security layer. That there's a dedicated session for it.
Sure. Thanks. That answers my question.
I have a question for you.
Yeah, sure.
Do you use any of these protocols like file formats or?
Yes, we use a ORC.
Please share that.
Sure. So ORC, okay. So when we have a data warehousing system in terms of Hadoop, so we use a different file formats, right? Text file format or Avro sequence files and all. So these are a different file formats which are available in a Hadoop ecosystem. So out of these, we have one of the formats like ORC. So when I say ORC, it groups a similar columns in a single bunch. When I say text format, all the columns for a particular row will be stored together, right? So if I need only let's say the example which Niraj has explained, so it may have 500 plus columns, right? If I have a huge data warehouse, it may have 500 columns. But I don't need all the columns. I don't need to analyze all the columns every time, right? I may need only whether customer has been purchased or not. I may need access. I may need to analyze only 10 columns. In that scenario, I don't need to scan all the records, right?
Yeah.
So that is the reason why these columnar structures came into picture. ORC, Parquet, and many other file formats are there. So if I use a ORC, what it does, it groups similar columns, or maybe based on data types or bits. So it stores in a different format so that you don't need to scan all the columns.
Yeah, and just to add to that particular point, it's a very good point. Just one second. From the data architecture side, if you think that's the problem, there's a new type of data structure that is there called column family. Read about it, what the column family is. Put all those related things into that particular family, because those column family will have a isolated, dedicated physical structure to it, right? So only that page will get scanned. Obviously, your data model will get changed, but there are abstraction layer which will make your things easy, like Phoenix and all those things. All right. So I think this was informative. Thanks a lot, and hope to see you again someday.